Welcome to the deep dive. We're here to pull out the key insights from important source material, and today we're diving into something called software conservation.
That's right. Our main source is a doctoral thesis by Federico Nicolas Báez. It's titled Principles of Software Conservation, a strategic framework for longevity, maintainability, security, and adaptability. And it's incredibly relevant now. We're seeing the fallout from years of just rapid, sometimes careless software development.
Yeah, conservation makes me think, like old buildings, maybe national parks, not lines of code. How does Baez connect that idea to software, especially against the usual move fast and break things tech mantra?
It's actually a really powerful analogy he uses, architectural conservation.
Yeah.
Think about maintaining a historic cathedral.
Right.
You manage its changes carefully so it lasts for centuries, right? Baez argues our critical software systems need that same kind of stewardship. It forces a shift, thinking in decades, not just release cycles.
Decades for software, that's ambitious.
It is. But it means having real strategies, like solid API versioning, thinking about backward compatibility from the start, treating software as a durable asset.
Okay, so let's unpack that framework. How does Baez pull together existing ideas like design principles under this conservation banner? What's the core?
Well, what's neat is how he reframes things we might already know as tools for conservation. Take the solid principles.
Right, familiar ground for many developers.
Exactly. So the single responsibility principle, SRP, it's basically one job per component. Violate that, and Baz uses this great image. It's like welding your plumbing directly to your electrical wiring.
Uh-oh.
Yeah. You change one thing, fix a leak, and suddenly the lights go out. It creates brittle software, really hard to conserve or maintain safely.
And he links that to LSP, the Liskov substitution principle too, right? The classic bird penguin example where a subclass can't just swap in for its parent.
Precisely. If your penguin object breaks things when used, where any bird is expected, because, penguins don't fly, you get these fragile hierarchies. They just crumble when you need to adapt the system later.
Makes sense. And DRY. Don't repeat yourself.
Oh, hugely important for conservation. He frames it as essential. Imagine if a complex pricing rule is copied and pasted across your shopping cart, your invoicing system, your reports.
Nightmare scenario for updates.
Total nightmare. A small change, maybe tax adjustment, becomes this massive risky project, hunting down every single instance. Neglecting DRY isn't just messy, it's a serious business risk. And kids keep it simple, stupid. That's just fundamentally making future conservation easier.
He also brings in Manny Lehman's laws, doesn't he? Like, software naturally changes and gets more complex over time.
Yes, the law of continuing change and the law of increasing complexity. Baez's framework is, in a way, a direct strategy to fight that natural decay, because entropy always wins if you just leave things alone. You have to actively invest energy.
Which leads us to maintenance, but not just fixing bugs, right?
Right. There's corrective, adaptive, perfective maintenance. But Baez really highlights preventative maintenance as the cornerstone of conservation.
Okay, what does that actually mean in practice?
It's the proactive stuff. Sharpening the saw, as they say. Refactoring tangled code. Upgrading dependencies before they become security risks. Improving monitoring.
This sounds like the stuff that's really hard to sell to management, though. It doesn't produce a shiny new feature immediately.
Exactly. That's the cultural hurdle. But the economic argument is massive. It's the classic ounce of prevention is worth a pound of cure.
Can you give an example?
Think about the Log4j vulnerability. Some companies, those with a culture of preventive maintenance, already had processes to update dependencies. They patched it relatively quickly.
And the others?
Weeks of panic, fire drills, auditing ancient code bases they hadn't touched in years. The cost difference, the risk exposure, huge. Neglecting this leads to what Baez calls software erosion, sometimes ending in technical bankruptcy.
Where it's literally cheaper to just scrap it and start over.
Sadly, yes. Then there's another fascinating angle in the thesis. Digital archaeology.
That sounds really niche. Preserving old software.
It is niche, but think about it. Sometimes we need to run old code, maybe for legal reasons, to retrieve data from an old system, or even to learn, like studying the Apollo guidance computer code for insights into ultra-reliable software.
But how do you even do that? Finding compilers, old operating systems.
That's the challenge. It's about preserving the whole ecosystem. As Baez puts it, data without its interpreting software is just noise.
So, okay, the principles make sense. The benefits seem clear. Why isn't software conservation the standard everywhere? What's stopping this?
Baez points squarely at human and cultural factors. Things like misinterpretations of Agile turning into feature factories
Mhm.
where quality takes a backseat.
Just ship it, ship it, ship it.
Right. And the hero developer anti-pattern. The genius who writes complex, undocumented code that no one else understands. That creates a massive liability, not an asset.
So the solution isn't just technical.
Not primarily. He argues it requires a management-led cultural shift, reframing the conversation about value.
So moving ROI away from just, did we ship feature X towards, did we reduce strategic risk Y? Like viewing refactoring as an insurance policy against, say, data breaches or system failure.
Precisely. It's about seeing engineering not just as building things, but as managing a critical long-term asset, taking stewardship seriously.
Báez's work really sounds like a call for, well, a more mature engineering profession, unifying these practices towards building things that actually last.
It truly is, being a steward for these systems throughout their whole life cycle.
It leaves you with a pretty big question then. What does it really mean to build in this digital age if what we create can just crumble away so easily into digital dust?
A sobering thought.
Definitely something to chew on. We encourage you to explore Báez's thesis if this sparked your interest. Thanks for joining us on the Deep Dive.